Welcome to High Tech Heroes, the show that takes you behind the scenes of today's high-tech industries, where you can meet the people and examine the ideas creating tomorrow's technology. And now, coming to you from the studios at Foothill College, high atop the mountains overlooking Silicon Valley, here's your host, Sherwin Gooch.
Hello, I'm Sherwin Gooch. Welcome to High Tech Heroes. Our guest this week is a super programmer and pilot who was born in West Germany. As a child, he took everything apart to see how it worked and always wanted to be an engineer. He attended Lake Park High School in Illinois, where he most liked the machine shop, but became interested in electronics and ham radio. At the University of Illinois, he learned to program and graduated in electrical engineering. Out of school, he became an on-site analyst for Control Data Corporation. Due to his reputation as a mainframe operating systems guru, he has often rushed to remote areas of the world to make emergency repairs. At the Purdue University CAD Lab, he became an expert at computer rendering of graphics, and his vectorized ray tracing algorithm is an industry milestone. He used the Cyber 205 supercomputer to render a computer-animated film, which has been shown in most OmniMax theaters. Our guest then optimized the I/O subsystem for the super-cooled ETA-10 supercomputer. He's now an independent consultant selling diagnostic systems for CDC machines and teaching Unix classes, as well as being curator of his own computer museum. It's now my pleasure to welcome super programmer and computer museum curator Joe Sykos to our program. Hello, Joe, and welcome to High Tech Heroes.
Hi, Sherwin. It's a pleasure to be here today.
Great. Well, I'm glad you got in okay from Purdue. It's a kind of a long flight. So, I understand you brought along some stuff from your computer museum to show us.
Yep.
So, what are you going to show us first?
Well, first of all, the first machine that Seymour designed for Control Data was the CDC 1604, and it was the first fully transistorized computer. And I have a photo here which shows the a machine room and the console. I kind of think of this as an early form of the workstation.
Yeah, I remember. It's a workstation that has octal readouts, right?
There's a little console which you use to program the computer. And the desk underneath the computer didn't reappear till in the early 80s when we had workstations such as Sun and the like coming on the market.
Yeah, that's a great old machine. You can tell here, I think it's stepped, in fact.
Could be.
Maybe, no, that's a jump switch. I take that. That's a jump switch. Anyway, so
the machine consisted of a number of modules.
Uh-huh.
And here's one of the modules.
And this thing has, the machine was made up of a bunch of modules like this?
Right.
About how many transistors in this machine?
There's 25,000 transistors in this machine.
And they all look like these individual transistors here, I guess.
Correct. And about 100,000 diodes. And I don't remember how many different types of modules there were.
So this was a DTL machine.
Right, and it used PNP germanium transistors.
Mm-hmm. Mm-hmm. And so there weren't very many different types of modules?
Well, again, I don't know the count. I can show you the photo of the machine, close-up view, which shows the memory.
Mm-hmm. Mm-hmm.
The memory is here on the right, and you see the module being extracted.
Yeah. Okay, so somebody's pulling a card out of the machine there.
Correct.
And this looks like it must be core memory over here.
Exactly, and that probably looks like a SenseAmp module or a driver.
Yeah, something to deal with the cores that close, I guess. Uh-huh.
So it consists of quite a few modules, even though many of these modules are the same. It's analogous to designing with integrated circuits, say, in the early 70s.
So most of the logic is in the back plane, I guess.
Most of the wiring interconnect is, yes.
Mm-hmm. Okay. Well, what machine are you going to tell us about next?
Well, the next major machine Seymour Cray designed for Control Data was the 6600. And I've brought a photo which sort of shows the machine room there.
Okay.
And in front of the machine is a console, and that's what intrigued me most about the Control Data machines and sort of started me down my career path with Control Data.
That's true. About the same time the 360 was built, and it had all switches and lights, right? And that's what people thought computers were.
And this was really nice. You could have a view of what was happening in the operating system. You can inspect memory there in real time.
In fact, I think there's a memory inspection, picture inspecting memory on the top of this display.
I brought a module with from that machine.
You did, okay. And what's this called?
And this is a cordwood module.
Mm-hmm. Yeah, we can see that.
And it's a pretty rugged module. There's two boards that have been attached together.
You can see both circuit boards there. And you can see the transistors are on the inside, hanging off of both boards.
And then there are resistors running in between the boards.
In between the boards. It's very hard to get the light in there, but yeah.
Yeah, I think if we rotate it sideways here,
yeah, there we go.
A bit there. You can see the components in there.
Right. Now, there's also an edge connector on the back, so there's pins that come off of each card, it looks like.
Right.
And they're both double-sided circuit boards.
Right, and there's room for about 60 transistors on each board.
And how many transistors per gate? I believe this was direct coupled transistor logic, so there's a gate for every transistor. So instead of having a whole bunch of transistors make up one gate, he gets one gate. This was designed by Seymour Cray, right?
And there's test points on the front.
Right.
Be used.
And the module name, a TD, I don't know what that means.
That's part of the clocking. And I don't really know where the name cordwood came from. It was used in the early Polaris system in the circuit miniaturization in that as well. And that was happening at about the same time. I'm going to explain the cooling in a little bit, but part of the reason for this type of packaging was to provide a way of dissipating the heat, and we'll discuss that in a little bit.
Okay. So what else do you have to show us?
To give you an idea of what some other computers were doing at the time, this is from PDP-1, and this is a dual flip-flop here. And this is early 60s machine. The 6600 came out in about 1964, I believe.
Yes. And what machine did you say this is from?
This is out of a PDP-1, and that's
okay. So that's about the same time?
About the same time.
So we have something where they packed 60 transistors in something this size, and it's hard to believe. Well, of course, the 360 was about the same time, too, and it was not very dense. Okay. This is mostly diodes here.
Yeah, there's a row of transistors there.
Oh, yeah, there are about 8 or 10 transistors here. Okay.
I've also brought some stuff from the IBM 360. Now, this is really from the late 60s.
Yeah, this looks pretty dense here. I mean, that's a 360, what model?
These came out of 36050. And in that machine, I believe IBM used like 5 different packaging types. And I have 3 out of the 5 right here.
Interesting. So I don't know what kind of packaging this is. Presumably these are all integrated circuits.
Right. There's 7400 logic on this one here, and it's.
I don't think this is the same. I don't think this is a 1964 vintage machine.
No, it's later. It's in the late 60s.
Okay, so this is more like 68 or 69.
Yeah, maybe even very early 70s.
Okay. So, do we have some memory here?
Well, first of all, I'd like to talk about the cooling.
Okay.
And I've brought a photo here which shows the machine open. And the modules were screwed down onto a cold bar. And Freon was circulated. This is one of the first, well, it is the first Freon-cooled machine. And the heat is then conducted away.
So this is just a large refrigerator?
Correct.
I mean, basically there's copper tubing that runs through it and pumped Freon.
Correct.
Freon has a heat exchanger, and then where does the heat go?
Then it's exchanged with water.
And then pumped out to the roof?
Yeah, pumped out to the roof, pumped outside.
Okay. So, and that was a breakthrough because this is the first time that they actually built cooling into the machine instead of just pumping air through it?
Instead of using forced air cooling or just convection air cooling.
Okay. Now you
Now,
have
the large squares in that photo were the memory module.
Mm-hmm.
And
let's see that. It
This
says
is
we have a label here. This says a storage module, and it says a serial number. So this is
Right.
memory.
there's 4K of memory here, 4K of 12-bit words. The machine was a 60-bit architecture. Used one's complement arithmetic in it.
So 5 of these make up one word,
Exactly.
one central memory word. Okay.
Well, it makes a 4K of one central word.
Yeah. Okay, and how is this constructed? We have, I can see electronics around the edge here. There's double sets of double circuit boards. They're sort of like the cordwood modules. There's 2 boards and
Exactly.
then components between.
And within here is a large chunk of core.
yeah, and I
layers stacked on
can't
top
see
of
the
each other.
core, but in the middle of it, I guess, is a bunch of core
Yeah,
memory.
these are very difficult to take apart. The memory used phased memory, in which allows you to, there were 16 banks in it, and it took like 1 microsecond to access one word. But if you could program such that you could access words contiguously, you could then get them at 1 every 100 nanoseconds.
So it increased the effective bandwidth considerably.
Right. And that was one of the architectural things. Another architectural thing in the 6600 was the concept of parallel programming. And they had 10 PPUs, which could perform many of the
Operations in parallel?
doing I/O, even the operating system. The early operating systems on that machine used about 2 to 4% of the CPU. And that's just unthinkable today.
Yeah. Now, what about mass memory? They have mass memory for that device?
They had ECS memory. I didn't bring an ECS core
How
plane
about
with
disk
me.
memory?
Well, there's a few other architecture things that I could talk about.
Okay. Well,
They had functional units on it, and this had parallel programming within the CPU, and there were 10 functional units. And so you could actually do an add and a multiply simultaneously. One last thing I'd like to show you is the mass storage device. And this is the Bryant disk system, otherwise known as the 6603 drive. And this is a 56 megabyte drive. It had 25, 39-inch platters in there. It was a very large drive, weighed 4,300 pounds. And it's about the size and capacity as your hard drives that you might find on your personal computer today, except for you don't have to worry about the floor caving in. I kind of wonder what the bytes per pound for that is.
Okay, well, Seymour Cray built a computer called the 8600, which is very famous among supercomputer aficionados. And I've never seen it or seen even a picture of it. But Joe is going to show it to us in a minute, right after this.
Hi, my name's Steve Jones. I used to play guitar with a band called the Sex Pistols. A good friend of mine, Sid Vicious, died from drugs. I nearly died from drugs. Drugs suck.